Okay guys, welcome back. Last week we learned about AC voltage, like AC sine waves, and we learned about how to calculate frequency and period by looking at the sine waves. Well, today we're going to learn about our AC voltage values. Also looking at sine waves, you might be wondering, how you figure out what the voltage is of an AC power source, because it's alternating current, so it goes from positive to negative, back to positive, and so on. So it's not a straight line, just a steady straight voltage like a DC power source is. So that's what we're going to talk about today, is how we calculate that. So the first thing I want you guys to understand is the degrees of a sine wave. Okay, so we have, of course, it's going to start here at 0, but the peak is called 90 degrees. Okay, the peak of the sine wave, like the highest point, or the lowest, but the highest point is going to be 90 degrees. And when it crosses back down, this is going to be 180 degrees. So right, we start at 0, up to 90, to 180, down to 270, and back to 0, and this is the start of the new sine wave. Okay, so the positive peak is 90 degrees, the negative peak is 270 degrees. So how do we define this voltage that is constantly changing? Well, there's 4 different ways that we can convert it. Okay, like 4 different values that we look at. There's the peak value, the peak-to-peak value, the average value, and the RMS or effective value. And I'm going to tell you how we calculate all 4 of these. So peak and peak-to-peak. The peak value is the value from 0, the center line, to the positive peak. So from 0 to what would be the 90-degree spot. So this spot, like right here, okay, the highest point on the positive side or the negative side, but the highest point. Okay, so let's say that this scale, we have 0, and right here we had 5 volts. Okay, let's say this line right here is 5 volts. That would mean that this would have a peak voltage of 5 volts. So this would be -5 down here, so this would be -5. So our peak voltage would be 5 volts. Peak to peak is basically where you just add them together. Okay, it's from the positive peak to the negative peak, or the negative peak to the positive peak, however you want to look at it. Okay, so in this case, if we're using that same scale, where this is +5 and this line's -5, together we'd be looking at a peak-to-peak voltage of 10 volts. Okay, so we add them together. We have 5 to 0 and 5 to 0, and 5 plus 5 is 10. So the formulas, and this is what I want you guys to write down. The formulas for these, so peak-to-peak equals the peak voltage times 2, okay, which makes sense because we're just adding them together, really. And your peak voltage, inversely, it would be peak to peak divided by 2. Okay, let me go back for a second. Hopefully that all makes sense. These formulas, after you do this enough, you should be able to just realize that peak is half of peak to peak, and peak to peak is just double your peak. Okay, this is definitely the easiest one. Okay, so now we're going to talk about average voltage. So the average voltage is the average of all the values of the positive alternation. Okay, so this was already figured out for you in advance using some calculus and stuff like that, which we're not going to go over that right now, right? But the value that you need to know is 0.637. Okay, again, that amount has been predetermined based on some different calculus, like a calculus formula. But you don't need to worry about that. All you need to know is that it is 0.637 is what you're going to be multiplying your peak voltage by to figure out the average. Okay, don't worry about how we came up with that number. It's not a random number I pulled out of the air. That is the right number. So you're going to multiply your peak voltage by 0.637. Okay, so there's the formula for that. And then inversely, your peak voltage is the average voltage divided by 0.637. Okay? Or peak, you could also do it average voltage times 1.57. Okay? Okay, now RMS, or effective voltage. This is the most important one. So RMS stands for root mean square. Okay, RMS is the AC value that would be necessary to produce the same amount of heat in a resistor as an equivalent DC voltage. So, in other words, in a circuit, let's say this, whatever this circuit is, this block here, let's say that's a circuit, it's a block diagram. Let's say it requires 12 volts DC. So, let's say the circuit could take DC or AC voltage. Okay, 12 volts RMS AC would be the same value. In other words, guys, the value that you usually look at when you're talking about RMS, like whenever we stick our meter, your multimeter, to measure a circuit and you switch it over to the AC voltage, that's going to be the RMS voltage, or the effective voltage. Okay, the meter is not going to measure the peak voltage. It's not going to measure peak to peak voltage. It's not going to measure the average voltage. It is going to measure the effective voltage, or the RMS voltage. Okay, so it is the one that we will use the most. So, root mean square value is the amount of AC required to produce the same amount of heat as its equivalent DC value. Okay, so the value we're doing with that is 0.707. Again, another time we'll go over how we got that value, but just know that that's the value. Okay, so for a true sine wave AC voltage, you can find the RMS by multiplying your peak voltage by 0.707. Okay. And Vrms equals peak voltage times 0.707, or peak voltage equals your RMS divided by 0.707, or peak voltage equals RMS times 1.414. Okay, and like I said, this is what we will use the most. Okay, whenever we eventually get back in shop, you're typically going to be looking at Vrms. So what you'll have is, when you use your O-scope, especially if you're using one of the older analog ones and you get a sine wave there, you're going to look at what your peak voltage is, and to figure out RMS, you're going to use one of these two formulas right here. Okay. Sorry, you're going to use this formula. My fault, because you'll be looking for RMS. So you'll do whatever your peak voltage is times 0.707. Okay, hopefully that makes sense. This is why we use oscilloscopes. You look at your peak voltage, and you can figure out what the RMS is. The nice thing about our digital ones is they do that for you. There's a setting in there. You can just click to measure Vrms, and it'll tell you exactly what that is. But for Nocti and our other tests that we do, you guys do need to know these formulas. So you need to know the 0.707, okay? And then obviously the 1.414 is just double the 707. So if the unit is not specified, like peak value, peak to peak value, average value, RMS value, like if I don't specifically say what I want it in, and we're talking about an AC circuit, you're always going to assume that it's RMS. Okay? Like when we say that a wall outlet is 120 volts, what we're talking about is 120 volts RMS. And actually, what you guys will find if you actually took a meter, an AC meter, and measured your wall outlet, you'll find that it is less than 120 volts. Just a fun fact. At my house where I live, it's usually sitting at about 112. Okay. The last comment, all these formulas and stuff I gave you, we're talking about voltage, but they could also be applied to current and power, right? So like current peak to peak, current average, current RMS, and the same with power peak to peak, power average, and power RMS. The equations are the same for those in regards to AC voltage and our AC power sources. Okay,